In the last video, we talked about what it means for a sample to be truly random and why that is important for a study. If a sample's not really random, then we introduce lots of bias into our study and we can't really rely on those results. So in this video, let's talk about some different random sampling methods. There are 4 basic sampling methods that we talk about. There are more. We'll talk about these. The first is basically a simple random sample. Great example of this would be you take everybody, put their name in a hat, and just mix it up, randomly select their name from a hat. A computer-generated system is often very helpful with this. A computer algorithm will be able to go through and then truly randomly pick some people out of a list of people. Now, if you know anything about computer programming, you'll know that it's an algorithm. It's calculated. It's not really random, but there are elements within the algorithm to make it simulate randomness. So it's fairly close. So we go with it. So simple random sample, everybody has an equal chance of being selected, and you just start selecting everybody at random. The second type of random sample we want to talk about is the systematic sample. This is where you have a starting position. You essentially line up everybody in a list or in a physical line. You randomly select a starting point and then choose a number, say 4, select every 4 people in the line. So I have everybody lined up. I pull out a random number, say 23. Then I go to person number 23, then 27, then 31, then 35, then 39, then 43, then 47, and so on, just going every 4 people down the line. You say, that's not random. Well, as long as everyone's randomly mixed up at the beginning, yes, it is random. If everyone's randomly mixed in at the beginning, then there's no predetermination in the order in which people are in the line. In addition to that, there's no predetermined starting point. We randomly select a starting point, so that introduces some randomness as well. Where would this be useful? A place where I feel this would be useful is, say, production. I worked at a grill when I was in college. I was in a restaurant and we made hamburgers and served ice cream. It was a really nice place. We loved it. That's beside the point. But I was in charge of our crew. When I was in charge, then we would start cooking. And then every 5 minutes, I would take the temperature of the hamburgers to make sure that we're cooking them to the proper temperature. And so essentially what you're doing, more or less, if you say you cook 20 hamburgers in 5 minutes, then I'm sampling every 20th burger just to make sure that we are correctly cooking it to the right temperature. That's an example of a systematic sample. Another example would be in a production line. You're making some product. You make 200 of these products. Look at the 200th one. What's the quality of the product? Good. All right, keep going. Make 200 more. What's the quality of the 200th product in that batch? So on. It's just a pattern to when you're going to take a sample to make sure that everything is still up to par. The next sampling method is stratified sampling. This is probably one of the most commonly used random sampling methods because it's a very good way to ensure that all the different aspects of a population are represented proportionally. So the way that this works is you take your population and you split the population into groups. And then you collect data from some members of each group. So this could work really simply as, we'll say, production factory making candy bars. They have a lot of different varieties of candy bars. So we take a sample of 10 candy bars from this type, 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 and so on. Perhaps a more realistic, well, that's a realistic example, but a more personal example of this that applies to you and me is if people are doing a study representing people, then you divide people into different groups, and you sample from each group. But some groups might be larger than others, so you might say, let's sample 5% of the people from each group. Let's do a simple example. You want to know you're testing something about students here at Snow College, and you want that factor of their major to be in this study. So let's say we're studying GPAs based on major. So you divide all the students into one major, and then more students into another major, and so on. Well, you have some very large departments where you have a lot of students majoring in those subjects: English, maybe mathematics, maybe life sciences. Nursing is a big one here at Snow College. And so let's say we have 100 students in each of those departments. 5% would be 5 people. But then let's say that you have a smaller department, like a fine arts department or a physics department or a computer science department. Let's just say that they're smaller departments. And we'll say 25 people in each of those majors. 5% then would be 1 person. Okay, so different size samples from each group. My point is that stratified sampling, you're looking at all the different groups and you can see them proportionally so that one group doesn't weigh more heavily than another without reason. Okay, and you can, depending on the study, you may say, I just want 5 people from each department, no matter the size. Or you may say, I want 5% of the department. Again, it depends on the study, which way you want. Either way, it must properly represent the groups. Cluster sampling is very similar to stratified sampling. You start off the same way. You separate your population into groups. And then instead of taking a few people from all groups, you take all people from a few groups. So with this study of departments across campus, maybe instead of taking a few people from each department, I'll say, I want all of the fine arts majors, the music majors. I want all of the English majors. I want all of the chemistry majors. And then you don't worry about any of the rest. Now, I'll be honest, that particular example I gave you, it could work for some studies. Probably not the best method. Let me give you another example where this would work really well, and that is teaching methods. Let's say that people in an education department have come up with a new teaching method for high school students, and they want to try it out. So they look at all the high schools across the state. So you have a bunch of high schools, individual groups, and they select 4 of them. This high school, they will apply the new technique. This high school, they'll apply the new technique. This one and this one, those 4 schools, they'll apply the new technique. All the rest are not tested. Apply the new technique and say, how well did it do? Okay, that's the idea of a cluster sampling. You divide everybody into groups. You randomly select a few groups and test everybody or everything in that group. Those are a few good examples of random samples. In the next video, we will look at couple of not so random samples.